Right. Today is the new topic for you, gravitational field. The main topic here is the force field. The force field mainly divided into three divisions. Now this is the today's topic, and the second one, this is called electric field. Electric field. And third one, magnetic field. Magnetic field. So these are the main three topics in the force field. So just little bit understand about the force field. Now when we consider the universe, in the universe there are mainly three force fields. Now the first one is normally what we familiar up to this mechanics part. This is the gravitational field. The gravitational field, let's say this is occurred due to the mass, due to the rest of mass. And later on I will discuss this part. The gravitational field produces due to the mass. Surrounding mass, there is a force field and it is called gravitational field. And the electric field, this is generated due to the rest of charge. Rest of charge. The electric field is due to the rest of charge. And the magnetic field, this is due to the moving charge or the current carrying conductor. So these are the mainly three force fields. Okay. And then I will start from this one. And the electric field, normally in your syllabus, we continue just after the current electricity. And the magnetic field just after the current electricity. Gravitational field, if we continue here, electric field, normally we should discuss after the thermal physics part. And the magnetic field after the current electricity. Without doing the current electricity, we can't discuss the magnetic field. That is the normal way, right? And this is very simple lesson. If we continue 2 hours per day, so we have enough 3 days for the gravitational field, right? And briefly discuss what is gravitational field, what is electric field, and what is magnetic field, right? Now, and here even I will not supposed to give a note to you, right? The first one is the gravitational field. Take it down. Under the force field, there are mainly three: gravitational field, electric field, and the magnetic field. Kanisha ma වැහෙනවද හොඳට? Yes, Kanisha. ඔයාලා message කොටන්න එපා. message දාන්න නැතුව කතා කරන්න ඕන. Everybody please talk with me, yeah? This is special online class. So there are some of you in Badula class, they are participating physically and you are only online. Right. Now, just discuss little bit about the gravitational field first. And today's topic, that one, we discuss more and more, and even the other two. Suppose this is the Earth planet. This is Earth planet. Now, this has a huge mass. This is called 6 into 10 to the power 24 kilogram, the mass of the Earth. So, when you place small mass surrounding the Earth planet, suppose simply, this mass has an attractional force by the Earth planet, that huge mass. This attractional force is due to the gravitational field. That unknown field surrounding these masses by the Earth planet, this is called the gravitational field. That means if there is a mass surrounding the mass, there is a force field. That force field, if generated due to the mass, it is called the gravitational field. This force is the gravitational force already we discussed. F equal mg. That means surrounding this mass, there is a force field. That force field is the gravitational field. Okay, take down this. Okay, right. And the second force field, and this is the electric field. Electric field. Suppose this is again the Earth planet, Earth surface. So normally the Earth is considered to be neutral, but suppose now this has a charge of minus q. This Earth has a charge of minus q. So when you put a charge of plus q here, again an attractional force on the charge by this huge charge. Okay. Now this is under the unknown force by this charge. This force called Fe. Earlier Fg, now Fe. This Fe equal to Eq. Now this force due to the charge. That means surrounding this charge, there is a force field. There is a force field. And that force field, this is symbolized as capital E. Earlier I forgot to mark that simple G. And we discussed now. The next topic, our gravitational field. This is the gravitation electric field. And this electric field is generated due to the rest of charge. This is not moving. This is a fixed charge. And this is a charge, but that has a mass even. Huh? So that is under the unknown force. And that force called electric force. So the electric force generated due to the rest of charge. In other words, if an unknown force field generated due to the charge, and it is called electric field. Second type of field, force field. Take down. Okay. Right. And the third one, that is the magnetic field. Magnetic field. Right. Suppose this is a current carrying conductor. This is a current carrying conductor. Surrounding this conductor, I think you can remind that in O level, magnetic field. Surrounding this conductor, there is a force field generated. That is given by the Maxwell-Coase rule. Can you remind that? Maxwell-Coase rule, if this is the screw and the head of the screw, when the current direction given by the tip of the screw, the head of the screw that rotating direction given by the magnetic field. That means the current when flowing this through the conductor, surrounding this conductor, a magnetic field generated. Magnetic field. Therefore, when there is another current carrying conductor here, this is I1, suppose this is I2. Because of the current here, there is a magnetic field generated. This is given by the Maxwell-Coase rule. That means in your right hand, so just keep that in two perpendicular directions, the thumb finger and the other four fingers. In your right hand, the thumb finger and the other four finger, when they are keeping two perpendicular direction, I vertically up, this is horizontal. The thumb finger when gives the direction of current, other four fingers that gives the direction of the magnetic field. Okay, now here, this is the current direction, then the right side, you can hear the sound. That means magnetic field towards the plane. Now, because of the magnetic field here, this current carrying conductor is under the force called unknown force, and that is attractional force. That force due to this unknown field, and this field is the magnetic field, and that force called magnetic force. Not only that, even here, there is same force but opposite direction. When the two current carrying conductors to the same direction keep in parallel, they have attractional force. They have mutual forces. And today I will not discuss this part, just the small discussion. Now this is the magnetic field. Surrounding this conductor, magnetic field. Due to the magnetic field, a magnetic force generated. If the current carrying here as a dot mark, that means outside the plane of the board, the magnetic field lines are here. These are the magnetic field lines. Yes, like this way. These are the magnetic field line. Take down this. Magnetic field. Finish. Okay. And now, again, the main topic, write down gravitational field. So we just discuss briefly about the force field, and now we'll move to the first topic, gravitational field. First topic, gravitational field. And I think everybody provide the tute. Gravitational field. Gravitational field. Now, if we discuss in more details, what is gravitational field? If you ask, the attractive forces created due to a mass or group of masses because of the gravitational field, right? The gravitational field normally defined as the force field generated due to the mass and maybe due to a group of masses. For example, like now in physically, some of you have participated here, Sinali here, and Sinuri and Shahanas, right? You three are now just like a lunar straight line. At the middle, Sinuri. Now they are ABC. This is B, this is A, and this is C. Right? Now, the B, mass B, is under two forces. So I can mark the front and the back, any other two masses, but enough this one. The mass B is in the middle area. That mass is under the two effect. One force attracting by A, that is small force, Fa. The other force due to C is a greater force, Fc. Now, the mass B just like in equilibrium. Why? Fc greater than Fa. Huh? They are not equal in forces. So, this is due to the gravitational field. Earlier, I just say the force field generated due to the mass, no? Yes. Now, maybe due to group of masses. Sometimes another mass if here, D, and another one here, E, some other mass forces, FD, FE, likewise. There are sometimes, if all the masses here surrounding the mass B, if equal in magnitude, I'm sure you can understand the net force on B, 0. Very good. 0. If all the surrounding masses equal in magnitude and same in distances, the net force on the mass B, that is 0. That is the gravitational force. Okay? Right. Then write down the, so I think it is better to write down the short definition for the gravitational field. Write it. What is gravitational field? Huh? The force field created due to the mass. Write down. The force field is created. The force field is created due to a mass or group of masses. The force field is created due to a mass or group of masses. The force field is created due to a mass or group of masses called gravitational field. So I will not supposed to give a note. So the note is printed. Right? Okay. Then the next topic, write down gravitational force field lines or the gravitational force line. Gravitational force lines or the gravitational field line. Okay, the next topic, write down gravitational field lines or force field line. Gravitational field lines or gravitational force field line. Right. So I will take an example for this one. Suppose this is Earth planet, Earth sphere. Here the center of the Earth. This is the radius of the Earth. And here the mass of the Earth. And just to keep in mind, normally you are given that as a data. The radius of the Earth is 6.4 into 10 to the power 5 meter. That means 6,400 kilometer. That is the radius of the Earth. And the mass of the Earth, that ME, 6 into 10 to the power 24 kilogram. The mass of the Earth, no need to keep in mind, just to the mass of the Earth 6 into 10 to the power 24 kilogram. And the mass of the Earth 6 into 10 to the power 24 kilogram, and the radius of the Earth 6,400 kilogram. Okay. Now, any of the mass surrounding this Earth planet normally attract by it. For example, so when I release this pen just about to the surface of the Earth, you know what happened? What is happening? This is falling down, and it is, come on, mechanics. When you release it, it is falling down, and it is, come on, it is when you release from the rest. Yes, Kanisha. Huh? It, when it is released, कोई Kanisha kata karanda. When it release, what happened? Huh? When you release it, what happened? Gravitational acceleration. It is accelerated. That is called free fall acceleration. Can't you remind that? So when it is falling down, the velocity gradually increases. And when it is hit to the ground, that has a maximum velocity. This is due to the gravitational force, gravitational field. And remember, this is falling along the gravitational force field lines. Suppose here, no any other mass surrounding it, only Earth planet in the solar system, no any other masses. Then the gravitational force field lines, when distributed, this is the way of they are distributing. So you can't draw that line inside the Earth. These are the field lines. All the masses surrounding it attracted by it. So can you understand? This is called G, field lines. That is called gravitational field intensity. So when the field lines close to the surface of the Earth, what happened? The field lines are getting closer. Field lines getting closer mean the field strength is high. When it is moving away from that, the field lines apart in each other. That means the field strength is smaller, decreases. When close to the surface, field strength is high because of closing. When moving away from the Earth, field strength is low because they are apart in each other. Can you understand? Right. And that is one thing. And remember, these field lines always normal to the surface of the Earth. All. They are normal to the surface of the Earth. Another one. Remember, these field lines never cross each other. These field lines never cross each other. They are always normal to the surface of the Earth. This is the Earth surface, and here the Earth center. So you can't draw the field line inside the Earth. You can't see them, right? So I just show you, but dotted line. So you can't draw them. These are the field lines. So inside the earth, no field lines. And the field lines are always right angle to the surface. When they are close to the surface of the earth, they are getting very closer. Away from the earth, away from the earth, apart in each other. So this is the direction that the mass moving when release it. So when you release, moving down. When they are released, again this direction. When this release, that direction. Gravitational force field lines. Draw the diagram. Raksha. There must be arrows, otherwise no gravitational field lines. Rule පාවිච්චි කරන්න. ඉරන්නේ පාට හෙම්බිරිස්සවද? හා? අපරාධ එන්න තිබ්බා පේපර් අද ලකුණු තිබ්බා අද වැඩිම 97 තිබ්බා. අඩුම තිබ්බේ 58. 58 අඩුම 52ද? sorry. 97. That's good, no? 97. Mirtesh, can you hear me? Mirtesh? Hello? No, you can't message. Talk with me. මේ මගේ online class එකේ කට්ටියට message කරන්න තානම් කතා කරන්න ඕන. Jabez, good evening. Jebes?
Good evening, sir.
Good evening. කතා කරන්නෙත් නෑ. ඔයාලා මොනවද තේරෙන්නේ නැත්නම් කතා කරන්න ඕන මැසේජ් කරන්න බෑ. Now finish. Okay, then the first question to you. This is one of the essay paper question, the theory part. Completed. Okay. The question is, draw the draw the gravitational field line distribution between two identical masses separated by the distance r. The gravitational field line distribution between two masses, two equal masses. Gravitational field line distribution between two equal masses separated by the distance r. This is one of the mass, the other one. And here again, suppose no any other masses surrounding this. I think you can draw this one. Only these two masses in the space, no any other masses. Then, so what the activity by the mass left side, that will try to attract all the masses surrounding it towards to here, while that done the same. Then, when I draw a line between these two at the midpoint, like all the masses in that direction, they are attracted to here, and they are attracted to there, and here they are attracted to here, and that one goes to there. This is same in magnitude, and other masses like here. All the masses attracting. Even that side the same. Here the same. This is the gravitational field light distribution between the two masses. But when you draw this line like here, it's a very beautiful than early, no? So like here. But you can't draw like that. So carefully. මෙහෙම අදින්න බෑ. මේ ටික infinity වලට යනකම් මෙහෙමයි. If this don't wrong. When you continue this up to infinity, same separation. And above 2, again same separation. Same separation. Right. Now I will erase this dotted line. Now, so when you keep a mass at the midpoint of the two masses, like 1 kilogram or any mass capital M, the force on this mass, because of this one left side, if capital F, the force on this mass because of that one right side, same in magnitude. Then the resultant force on simple M, capital M, 0. So this point called neutral point of gravitational field. What is called that? Neutral point of gravitational field. So do you have some experience like this? Neutral points? So I think you have seen that in the social media. There are some places in the especially artificially built up. So when you just enter to that area, your weight becomes 0. Not vacuum. So you have gravitational force down, a same force but upward direction. Then the net force 0. There are sometimes when you fed up the lesson and even continuously 5-6 hours, that time sometimes we feel in some you are floating like. This is not. This is really the net force 0. මේ වගේ තැනක මෙහෙම ඔයාලා මෙතන නම් ඔය තැන මෙතන මෙහෙම ඔයාලා රිලීස් වුණොත් වැටෙන්නේ නැහැ පහළට. උඩට යන්නේ. They are waiting the same level, equilibrium. No net force. Okay, take down. This is very important. මේක theory නෙවෙයි question එක කැලක් දුන්නේ. Gravitational field line distribution between two masses. The topic, gravitational field line distribution between two masses. Gravitational field line distribution between two masses. Aksha Pau gaya tera joint and be. Aksha. She went home. Or paper banduna. She asked. What can we know? I hear a thing from it. Yet we are calling it. Magin Karagatine. Recording a band can. No. Oi. Kaligatta? Again. So when you draw this one, please remember this should be parallel, finally parallel, and even these two parallel, this especially. Okay, right. Then the next topic, write down gravitational field intensity. Gravitational field intensity. Gravitational field intensity. Gravitational field intensity. So you seem to be, this is some difficult topic. This is very common to you. Early we discussed. This is the gravitational acceleration. Right in the bracket. Gravitational field intensity means simple G. Gravitational field intensity. Simple G. Gravitational field intensity. Right. Again, this is the Earth planet. The mass of the earth at the center of the earth, ME, and the radius RE. Right. Suppose we place a mass of simple m in the field of gravitation. The mass simple m, when placed in the field of gravitation, that has an attraction force by the earth center towards the earth center. Suppose if the gravitational force on the mass simple m is capital F, the gravitational force on the unit mass, that is F by simple m, and this is called as the gravitational field intensity. What is the definition? The gravitational force per unit mass placed in the field of gravitation. Again, the gravitational force per unit mass placed in the field of gravitation. That is called the gravitational field intensity. Now, the force when measured by Newton and the mass measured by kilogram, this is measured by Newton per kilogram. But you know, this is again equal to, yes, ms minus 2. How it is equal? Newton mean kg ms minus 2 into kg minus 1. Cancel. Then ms minus 2. Okay. And by doing the cross multiplication, you can write it as F equal mg, the first equation. First equation. What are the units? Newton per kilogram or ms minus 2. And the equation F equal mg. Right? And the gravitational field intensity is a vector. Can you remind that in mechanics, at the beginning, equation of motion under the gravitational motion? So what we consider there, the gravitational field is a vector. It is vertically down. Now, just keep out from the mind now. Gravitational field intensity is a vector, but that direction is always towards the earth center. Here, this is the direction of G. And here, this is the direction of G. And here, this is the direction of G. And there, this is the direction of G. G is always towards the earth center. In mechanics, what we consider only the motion vertically down, no? Yes, always vertically down. But that depending where we are. If you're in Sri Lanka, at Badulla town and my residence, here, G vertically down. And when we are another country, another place, again vertically down. But when whole planet we consider, this one and that one can't say vertical down. Depending. That vertically down mean depend on the place we are. Write down. Can you write down the definition? What is the definition? Yes, the gravitational force per unit mass placed in the field of gravitation. Write down. The gravitational force per unit mass, the gravitational force per unit mass placed in the field of gravitation. The gravitational force per unit mass placed in the field of gravitation. Aksha join. Aksha, we discuss about 45 minutes. Just control from here and repair the recording. Na?
Okay, sir.
So online student, please submit your email address then only you can refer the recording now. And please remember, no one can share the recording. If you share the recording, you can't see it again. හැම එක්කෙනාම මේ මේල් ඇඩ්‍රස් එක මට මැසේජ් කරන්න. මේල් ඇඩ්‍රස් එකට තමයි ඔයාලට ලින්ක් එක ඇටච් කරන්න. So the definition very important, everybody. Write down the definition accurately. The force per unit mass placed in the field of gravitation, that is the gravitational field intensity. And the units Newton per kilogram or ms minus 2. And it is a vector, write down. Simple G is a vector. Direction towards to the earth center. Finish. So everybody write down the definition and so normally what I discuss, please write down it and refer the record note also. If in doubt, you can refer the recording again. Right. And the next topic, Newton's universal law of gravitation. That is the first law actually, very important. Write down. Newton's universal law of gravitation. Newton's universal law of gravitation. මේක පොඩ්ඩක් හදලා තියෙන බෝඩ් එකේ මන් දින එකක් දැයිද නෑනේ. Right. Now this is very, very important. Like I told you that earlier, the electric field, the gravitational field, and the magnetic field. So there are three parallel laws. Here the Newton law of gravitation, and electric field again parallel equation, and the magnetic field again parallel equation. And there are some properties, they are depending on the field type. Suppose these are two masses, and the masses m1 and m2, and they are separated by the distance r. They are separated by the distance r. Okay. When the two masses of m1 and m2 are separated by the distance r, so there is a mutual force, and the Isaac Newton, he found that this is always attractional force. So that's why at the beginning U3 ABC call and draw in the diagram and mark their forces attractional force. Newton found that when two masses are separated by some distance, there must be always an attractional force between the two masses. So they never repel from each other. But in electric field, we call there are like charges repel from each other, but unlike charges attraction. No. Like charges are repelled from each other, but the unlike charges are attracted. But there are sometimes, rarely, even like charges are attracted. Now, this is one of the force, F. The other one. These are the two forces. So, these are called mutual force. So, they are attractional force. The Newton law of gravitation that says the first one, this gravitational force between the two, they are mutual forces that proportional to the product of the two masses. And secondly, that inversely proportional to the square of distance between the two masses. The gravitational force between the two masses directly proportional to the product of the two masses. Not only that, and inversely proportional to the square of distance between the two masses. When joining between two, you can write it if proportional m1 m2 divided by r squared, and then using a proportional constant called capital G. Capital G is the proportional constant into m1 m2 divided by r squared. This is the second equation of gravitational field, and where capital G called universal gravitational constant, and this capital G equal 6.11 into 10 to the power minus 11. And can you please tell me the units? When G subjected, here Newton, and here squared meter, and there per squared kilogram. In other way, yes, kg minus 1, m3, m to the power 3, s minus 2, same. And the dimension of capital G, that equal m minus 1 L to the power 3 t minus 2. So no need to rewind this one. Normally you are given that in the exam papers. Okay. So this is the Newton law of gravitation. Now, everybody, even online students, now tell with me, what is Newton law of gravitation? When two masses of m1 and m2 are separated by the distance r, the mutual attractional force between the two masses directly proportional to the product of the two masses and inversely proportional to the square of distance between the two masses. Again, when two masses of m1 and m2 are separated by the distance r, the mutual attractional force between the two masses directly proportional to the product of the two masses and inversely proportional to the square of distance between the two masses. Take it down. Now you can check it again, the Newton law of gravitation. When two masses of m1 and m2 are separated by the distance r, the mutual attractional force between the two masses directly proportional to the product of the two masses and inversely proportional to the square of distance between the two masses. Finish. Right. Okay, then we'll move to the next topic, the properties of the gravitational field. Gravitational force. Properties of the gravitational force. Write down. The properties of the gravitational force. Properties of gravitational force. Properties of gravitational force. So, what are the properties? So, there are actually 5 properties. So, this is very important. And you can compare that with the electric forces. The gravitational force, first one, is a mutual force. Mutual force. That means even the masses are different, right? The gravitational force always equal on each other. This one m1, that one m2. Even the masses differ. The force on the mass m1, the force on the mass m2, they are same in magnitude. They are mutual force. Okay. And the second one, the gravitational force always attractional force. Attractional force. No repulsive forces. And third one, act along the line mass extending. That means the masses here, like here. So this is always along the line extending, two masses. And the fourth one, this gravitational force mainly act due to the mass. The force exerts due to the mass. And the last, this obey to inward law of square, inward law of square. That means the gravitational force, how change with the distance is like this way. That means if proportional 1 upon r square, this is the way. The r distance when increases, the force decreases. That is always along the parabolic path. That's why I call F proportional 1 upon r square, inward law of square. The distance when increases, the gravitational force decreases, not a straight line in a parabolic path. So have you completed the Boyle's law? Chemistry? Gas laws? How do you plot the Boyle's law? P versus V shape. This is the parabolic shape. That means F proportional 1 upon r square. Okay. These are the properties. So mutual force and attractional force, always attractional force, and act along the line of the mass extending, and the force exert due to the mass, the force occurs due to the mass, and that obeys to the inward law of scat. මේ graph එකක් දාගන්න මේකත් ලියගන්න. Right, that is the first part of the theory we completed. Now first question, let's select a simple question. Question number 10, and then question number 8, and lastly question number 15. The MCQ2, you have only 5 minutes, and for the essay, about 10-15 minutes. Now start. Question number 10 and 12. Question number 10, sorry, 10 and 8. First 10 question, then 8 question, and then 15th one. Start. Right. Question number 10. What is the answer? Huh? Fifth one. Yes, online. Question number 10, answer. Kanisha. Now the question. An object weight 100 Newton on the surface of the earth. This is the earth surface. When it is placed here, that force F1, that is 100 Newton about the mass M. Okay. Here the radius RE. Here the earth center. Suppose this mass ME, mass of the earth. That means this F1 equal capital G ME simple M divided by RE square. This is given as 100 Newton. That is to the law of gravitation. So when it is carried to a height of equal to the radius of the earth, that means now it is taken it up to here. Another radius RE. The new force, suppose F2, the mass again M. Then F2 that equal capital G ME simple M in divided by 2 RE square. This is capital G ME simple M divided by RE square into 1 upon 4. So what is this? 100 Newton divided by 4. That means 25 Newton. So very good. 100 ne? Huh? ඔයිද ඔන්ලයින් කට්ටිය මොකුත් ප්‍රතිචාරයක් නැහැ. ආසිම් no reply. So how did you find that 100 Newton? Huh? අදාළ නැහැ කියලා හිතුවා. Then අදාළද බලන්න 8 question number 8. That is the early theory I have taken. ABC. A M1 B capital M. We'll take capital M to the mid now. Shehana's mid. And similarly right side. And similarly left side M1. Question number 8. Yes. Answer second one. Second. What is the answer? Second one. Second one. Second one. Second one. Second one, yes. Correct. Second one, correct. ඒකත් නේ අරක බැරි වුණේ. Right. Question number 8. This is again a mass capital M, M1 and M2. This is the line extending between the three. So the left side, the distance between capital M and M1, 3A. Here up to there. And this is how much? Arth? Huh? 2A. 2A. Initially, they say the mass capital M at rest. That means Due to the mass m1, a force on this side f1, and due to the m2, that one f2. If the mass capital M at rest, f1 equal to f2. What is f1? Capital G, capital M, simple m1 divided by 3a squared. And what is f2? Capital G, capital M, simple m2 divided by 2a squared. Equation 1. And secondly, what should be done to the R2 value to keep the mass capital M at rest when the mass M1 double? Now the left one, the mass double. Then R is to be new value. Suppose when M1 become 2M1, this is become F1 dash. And this is if new value like X, this is suppose F2 dash. Again, these to be equal. Now you can write it again. F1 dash equal to F2 dash. What is F1 dash? Capital G, capital M, 2M1 divided by 3A square. And right side F2 dash, capital G, capital M, M2 divided by X squared. Second equation. Now, when you get the ratio between the first and the second, yes, the left side, capital G, capital M, M1, 3A squared divided by this one mean 1 upon 2. Can you understand? And the right side, when this is divided by that one, capital G, M, M2, capital G, M, M2 cancel. And that should be X squared by 2A squared means 4A squared. This is again cancel, 2 remaining. Then X squared equal to A squared. Then what is X equal? Root 2A. Root 2A. Finish. हमारे බෞද්ධක බලන්න දීලා වැඩක් නැහැ වුණා. ඉතින් ගන්න ඕන. මට කරපු ඉතින් when first one divided by second one, these are whole that side only 2 additionally. That is why 1 upon 2 remain. Okay. Shall we move to the 15th question? Right. So I will not discuss the theory part. State the Newton's law of gravitation first. Right, that is okay. The two equal masses capital A and B of mass 100 kilogram are placed on a light rough horizontal surface where no other objects are present. That means you are not to assume that any other gravitational force on this. The attractive forces on capital A and B due to the earth are vertically downwards. The distance between the center of gravity of the two objects is 0.1 meter, as shown in the below. The coefficient of static friction between the rough surface and the objects are 0.1. Universal gravitational constant given. Find the magnitude of the gravitational force exerted by on B by A. Show the direction of the force on B. Now this is the light horizontal surface. This is the mass A and the mass B. Mass B, right? So this is the center of them. Separation between the two, 0.1 meter, right? So the force on B by A towards to here. And the force on A by B towards to there. They are into equal magnitude. Now this capital F equal capital G into M squared divided by R squared. Capital G, I think they are given very short value, 6.67, no? 6.67 into 10 to the power minus 11 into M squared 10 to the power 4. 100 into 100, no? Huh? M mean 100. 100 into 100 mean 10 to the power 4. Divided by R squared mean 0.1 squared. That means 6.67 into 10 to the power minus 11 into 10 to the power 4 divided by 10 to the power minus 2. 0.1 mean 10 to the power minus 1 of squared mean minus 2. This minus 2 minus 11 minus 9 plus 5 minus 9 minus 5. That means the answer 6.67 into 10 to the power minus 5 Newton. Anybody? This answer? Yes, very good. All right. And the second, the direction I have shown here. This is the direction FPA. That means the force on B by A. Direction, okay. Will a frictional force act on B? If so, find its value. Are there any frictional force on B? Definitely. Where the direction? That direction. FFB. What is the frictional force now? How much? Mu given 0.1. How much? 100 Newton. That's shown. The frictional force on B is 0. Why? So not 0, sorry, very sorry. The frictional force on B here, that FFB, that equals 6.67 into 10 to the power minus 5 Newton. Same as the force on here. You calculate the limiting frictional force. Yes, limiting frictional force FLB, that equal mu into RB. That is mu into 0.1 into RB mean 1000. That is 100. It's okay. That is limiting frictional force. They are asking about the friction force. You know the graph of force versus frictional force, that is straight line go to the origin. You calculate this maximum value, that 100. We don't need that term. They are asking about somewhere like here. Okay. And the third part, will B move towards A due to the gravitational force mentioned in 1. Explain. Now B moves to the left side. No. Not moving left side. Yes, very good. Why? Because the frictional force also the same but opposite direction. Therefore, the net force 0. Very good. The B not moving towards to A because the frictional force same in magnitude but opposite direction. That is why it is not moving left side. And the last, Find the minimum mass that A should have to move B. Yes. Now we need to move B towards to A. Then the minimum mass of A is to be calculated. Suppose the minimum mass of A should be M dash to move this one to the left side. Then the new force, suppose F dash be A. And now this is FLFB, limiting frictional force. Now the net force 0. Then you can write it F dash BA that equal FLFB. That means the limiting frictional force calculated Newton in 100. Now this is capital G, capital M dash divided by 0.1 square. That equal 100. This is 6.67 into 10 to the power minus 11 into capital M 100 into M dash divided by 10 to the power minus 2. So that equal 100 Newton. Now do the calculation. Find the new M dash. ఏదేంలా మై 1.5 into 10 to the power 8 kilogram. Yes. Okay, write down online. the mass, minimum mass needed to move the B towards to A, 1.5 into 10 to the power 8 kilogram. 1.5 into 10 to the power 8 kilogram. Right. So now we have another 15 minutes. Shall we discuss another theory? Right on the topic, gravitational field intensity around a mass. 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 Remember, majority of the classes, what they are doing in the gravitational field, just only 2 hours. They are given the equations and no question to discuss. You have to do the questions. All the equations given during 2 hours. Not only here, even Colombo side, Candy side, they are given only the equations and you have to do the questions. Okay. But the gravitational field is a longer lesson when doing the questions. There are some questions. Sometimes the half an hour question may be taken more than 1 hour. Simplifications. So that's why I selected at the beginning to do that, to get the experience. Right, the topic, gravitational field intensity around a mass. Gravitational field intensity around a mass. So the around mass mean I consider again the Earth planet. Earth planet. This is the Earth center. The mass of the Earth, ME. The radius, suppose RE. Now, I will consider a mass placed by the distance simple r from the Earth center. Suppose the mass simple m. Now, there is a gravitational force on the mass simple m towards the Earth center because of the Earth gravity. Now, that F can be written as, to the Newton law of gravitation. Yes, we can write it F equal capital G capital M simple M by R square. To the the gravitational field intensity, Jan 1. To the gravitational field intensity, we can write it again F equal mg, where G is the gravitational field intensity at M. I have taken this one now earlier. And by equating the first and the second, what can you write? Mg, second equal to first one. Mg that equal capital G capital M simple M divided by R square. Mg equal capital G capital M simple M divided by R square. Simple M cancel. Then G equal capital G capital M. Actually M mean ME. ME divided by R square. This is the next equation. Third equation, I think. Third equation of gravitational field. And to this equation, so actually simple G that directly proportional to 1 upon R square. 1 upon R square. And we can have very specific equation using that common equation. Suppose the mass here A, when you place the mass at B, the same mass simple M, this new force called F naught. The new field intensity, suppose G naught. Then at B, you can write it again, G naught equal, so refer this equation. How? G naught equal, come on, G ME unchanged divided by, instead of R squared, here RE squared. Very good. This is the next equation. Equation number 4. In other words, you can rewrite as GME that equal G naught into R squared. This is very common equation for the simplification. Now new equation. Same equation number 4. Do it. යුනිෆෝර්ම්මයිට මහන්සිද? මහන්සි. ඊළඟ දවසේ පේන 8:00ට ඉවර. මහන්සිද? ජන ඉස්කෝලේ ගිහලා දාන්නේ. ඒකනේ. නේ කිනේ. මම ඉස්කෝලේ අඩුයි නේ. එන අමසක වෙන්නේ නැහැ කියලා. ඉස්කෝලේ නැහැ කිව්වනේ. equation numbering හරියටම දාගන්න. equation කීයද? 4යිද දැන්? only 4 equations. So what is G naught? Yes, what is G naught? I have marked here. What is G naught? Gravitational field intensity on the surface of the earth. So normally that is be considered as 10 ms minus 2. And beyond to earth surface, simple G decreases. And now I plot that graph. Right. Now write down the next topic. Simple G versus, or the gravitational field intensity versus distance. 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 Right. So I will take that, divide into 2. Right on the first one, under that first one, from the earth center to the surface. From the earth center to the surface. First one, from earth center to surface. Now this is the distance measures, and this is the field intensity G. To discuss that, I will consider a common distance x from the center. Common distance x from the center to the surface considered. And I will assume the mass at here as simple m. Okay. So that equation earlier we obtained, suppose the point here field intensity is G. Field intensity is G. Then G can be written as capital G M divided by x square. Simple G can be written as this. G is the point where here A. Field intensity G. G can be written as the distance from the center to here x. Then the mass up to this M. G equal Gm by x square. And suppose the Earth planet is a uniform sphere having a mean density rho. Actually, the Earth sphere consisted of two, no? The mantle and the core. Core is again two types, inner core and the outer core. So that has different density. So forget about that. Now assume that the whole sphere, Earth sphere, has a mean density rho. Then this mass can be written as the volume into density. And the volume can be written as 4 by 3 into 5 x to the power 3 into rho and subject to there. Then G equal, so normally you are given this graphs just to keep in mind, but I will prove here. Then no one can remind it. Tamash is sleeping. Huh? M 4 by 3 5 x to the power 3 rho divided by x square. I just first time I saw that you are sleeping. Huh? Now you see x squared and x cube cancel, 1x remaining. Then 4 5 G rho divided by 3 into x remaining. This is G. So what is actually inside the bracket? 4 constant, 5 constant, G constant, rho constant, 3 constant, all are being constant. So how G changes with x is G equal K into x. That means G proportional to x. Then the graph of G versus R from the Earth center to the surface is how? Like this. A straight line gone through the origin. Where here RE, surface of the Earth. The distance from the center to here RE. And the field intensity there is how much? 10 ms minus 2. This is ms minus 2. That is the first one. From the Earth center to the surface. So before plotting this graph, or just plot this graph and right side for this one. So I think we have no time to do that again. ඊළඟ දවසේ තමාෂා ඉස්සරහම පෙළේ. ටෝක් එකට මෙහෙම වෙනවා. සාමාන්‍යයෙන් නිදාගන්න වෙලාවට ගෙදර. මේ දවස්වල මාර්ටින ඔක්කොම ආගේ ටයිම් ටේබල් එහෙම. 8:00 10 වෙනකන් ගත්තා නම් හරි. ක්ලාස් එක. එතකොට හොඳටම බලාගත්තා. එතකොට අර හීනෙන් දොඩවන්නේවත් ආගන්න පුළුවන්. නේද නේද? ඔය ඩයග්‍රෑම් ටික ලොකුවට ඇඳලා ලස්සනට වැඩි කරගන්න. ඔයාලා හරි ලකියා. 2024 ට මේ කරේ දැනට මාස 4-5කට කලින්. මම හිතුවා 4-5 හිටිය අයියේ ගහන ගෙදර ගිහලා හිටියද ග්‍රැවිටේෂන් ෆීල්ඩ් අහන්න එහෙනම් ඉන්නද. So if you are difficult to understand this when it is plotted on the same diagram, then you can separately plot the graph. G versus R from the center to the surface. අපේ ටයිම් එක ඉවරයි මට විනාඩි දෙකක් තුනක් දෙන්න පුළුවන් නම් මේක ඉතිරි එකත් ඇඳලම දෙන්න පුළුවන්. ඒක ප්‍රූව් කරන්න දෙයක් නැහැ. Huh? I just discuss. If you need, you can refer that recording again. From the surface to the infinity, when consider second one, from the earth surface to the infinity. Then I will consider another mass somewhere like here. Right? Now we measure the distance from here up to there. Right? Now what happened? G equal, when I apply G, m dash upon r squared, m dash mean what? M dash mean from here up to there. Actually the surface only up to here. And beyond to that atmosphere. The mass of air negligibly small compared to the mass of the earth. The mass of the earth mean 6 into 10 to the power 24. Mass of the gas, a certain volume, that is negligibly small because the density of air 1.2 kilogram per cubic meter light. But the density of earth is huge value. Today I will not calculate, next week I will give that. It's a large value. Therefore, the air is negligibly small. That means that m dash almost equal to m. M mean me. M dash means the total mass now. From here up to there, that is almost equal to the mass of the earth. Then we can write it again. G equal GME divided by R squared. Now, this GME constant, mass of the earth. Then what happened? G proportional 1 upon R squared. Therefore, beyond to the earth's surface, the graph is again parabolic because G proportional 1 upon R squared. That proportional 1 upon R squared. If you need separate graph, this is the graph of G versus R beyond to the surface. Like this way. Okay. Now here RE. This is 10. The graph of 1 upon R square. And from the earth center to there, it's a straight line going through the origin. And this one proportional R. G proportional R. And this one proportional 1 upon R square. Okay. Take down that. So I think our time is okay. Oh, yeah. Hmm? Now the exam paper MCQs, yeah. That one complete MCQ. The field intensity versus distance from the Earth center to the infinity, a single graph. Or part colors දෙක තුනක් දාගන්න නැත්නම් පැහැදිලි නැහැ. ගෙදර ගිහලා හරියට ඇඳගන්න. ඔයා හරිනේ. හරි. Now remember, now this is meet the x-axis at infinity, yeah? Not here. මේක ගාවන්න එපා x-axis එකේ. max කරන්න අය දන්නවා. නේ? infinity එකේ මුල ගහන්න. Okay, then shall we stop?